webinar, I would request our HOD to speak a few words for this webinar. Dr. Ghosh, please.
Yes. So, good evening, all the participants and Professor Gautam Sutradhar. Today, we are privileged to have Professor Gautam Sutradhar, Honorable Director of NIT Manipur, as a speaker. We must thank Professor Sutradhar for accepting our invitation instead of his very busy schedule to give a lecture on his area of interest. On behalf of the whole metallurgical and materials engineering family of NIT Durgapur, and on my personal behalf, I express a warm and hearty welcome to Professor Sutradhar in today's online interaction session. We have organized several webinars in the last 6 months. All these endeavors during the pandemic situation are to make the industry institute interaction live using the online platforms. Earlier, we have conducted several 1 day, 2 days or short-term programs, seminars, etc. in physical mode at our department during the last 2 years, when the expert professionals from industries, eminent researchers from R&D organizations or academic institutions have been invited to give lectures here. We have conducted the industrial tours also to give students some exposure on the processes and activities happening in plants. These sorts of interactions benefit both the sides and very much essential for the overall development of the country. And this has become very relevant when we are moving towards Atmanirbhar Bharat. But during the pandemic period, we have no other way but to continue the interaction with industries, with R&D organizations in a virtual mode. I feel today's program is a special one in the sense that this is the first time when the director of a NIT is giving the lecture to our students, scholars and faculties on his research and research interest. Professor Sutradhar will be talking on foundry as an entrepreneurial area in today's world. This is a very important area and the students should know about it. We are now thinking about Atmanirbhar Bharat, and so we should be much concerned about the Indian condition and should produce everything in-house. We are very thankful to Professor Sutradhar for his support to speak in today's webinar as a resource person on a very important topic. I hope the participants, students, researchers, faculty members will enjoy his talk and will be immensely benefited from his deliberations and will surely gain some valuable information and knowledge. I wish all the success of this program. The program will be a grand success, of course, if some of the participants use the concept gained from this platform to shape their future as a successful entrepreneur. With this hope, I thank you all once again, and especially I thank Professor Sutradhar for coming forward to give this lecture instead of his very busy schedule. Thank you once again all. Over to Professor Pramanik. Over to Professor Pramanik.
Thank you, Professor Ghosh. So to start with the lecture, straight with the lecture, I would like to introduce Professor Gautam Sutradhar to all the participants. Dr. Gautam Sutradhar did his BTech in Mechanical Engineering from Jalpaiguri Government Engineering College and his Masters from IIT Kharagpur and PhD from BITS Mesra, Ranchi. After 5 years of industrial experience in Hindustan Motors Limited and Indian Railways, he joined as a faculty at NIFT, Ranchi. After that, he served Sirampur Textile College and Kolani Government College for about 10 years, and finally he joined as a professor, Department of Mechanical Engineering, Jadavpur University. Presently, he is on leave to act as a director of National Institute of Technology, Manipur. He has guided 20 MTech theses and more than 16 PhD students. He is actively engaged in Foundry Cluster Development Program initiated by TIFAC New Delhi and MSME West Bengal. He has authored 2 books like Design and Manufacturing and Integrated Approach from Oxford and IBH, and Foundry Process Design from New Age Publishers, New Delhi. He had published more than 75 technical papers in referred journals. He is the chairman of Eastern Region of Indian Institute of Foundry and a fellow of Indian Institute of Engineers. He had advised more than 60 MSME foundries of Howrah region, Rajkot region, Viwadi region in individual capacity and on behalf of Indian Institute of Foundrymen and also Jadavpur University. He was involved in the manufacture of value-added products for railways, rail, with the help of computer-aided simulation software. With these few words, I request Professor Gautam Sutradhar to start his lecture. Sir. Yes.
Yes. Fine. Professor Sutradhar.
Presented screen share.
তো কোথায় ছিল এই ডাব্লিউতে আছে না ঠিক আছে এটাই প্রথমে থাক ফ্রম দ্য ইয়ে করে দেয় স্লাইড শো থেকে ওকে থ্যাংক ইউ হেড metallurgy engineering department NIT Durgapur. Am I audible?
Yes.
Am I audible?
Yes, fine.
And also thanks to Dr. Sapan Paramanik for nicely introducing me. So what I felt that I will give some tips how actually an engineer is facing in a shop floor. Okay. So during my last almost 25 years, I am closely attached to it shop floor. Okay. In spite of my schedule in Jadavpur University and other engineering colleges, in average, there is no week that I do not visited any foundry. Okay, it was my passion initially. So I slowly, I have developed many things. And to be frank, when a person is really got some knowledge in this, then he will get enormous amount of jobs. Okay. Initially, students may think that this metal industry do not pay much. That is why this industry could not attract our good students. Even I have seen in Jadavpur, even I have student in Kolani Government Engineering College. Even today I am seeing in NIT Manipur also. On the other hand, industry, they are actually looking for the students who are really know at least something about this metal casting industry. Okay. So because one information I have just giving, I am interested to give to my students of NIT Manipur, NIT Durgapur, that particular this casting is basically needed right from railway products, right from automobile, then earth moving elements, and then shipping industry, then where not, casting in using for machine manufacturing also, machine tool manufacturing also. So therefore, there is a huge demand in this castings, either it is a steel casting, or it's a cast iron casting, or it's a copper casting, or aluminum casting. You will be surprised to know that there in globe at present there are only 10 countries are there who are producing the castings and supplying all over the world. And India stood the second position in that. First is China, who is producing about 40 to 45 million ton of castings. India is only 10.
কি করতে হবে একটু একটু
শুনতে পাচ্ছেন নাকি?
একটু হোল্ড করুন না এটা একটু আগে এটা করি নেট স্লো আছে
শিবেন্দু ভিডিওটা অন করো ভিডিও
অন করতে বলছে
নেট স্লো আছে এখানে নোট তো নেওয়া হয়নি অ্যাকচুয়ালি জিও থেকে চলছে এটা
তো ওখানে ব্রডব্যান্ড কানেক্ট করে দাও
ব্রডব্যান্ডের এখানে পাসওয়ার্ড কি আছে
আরে জিজ্ঞেস করো না গেস্ট হাউস
পাসওয়ার্ড আছে পাসওয়ার্ড আছে ওদের কাছে আচ্ছা ঠিক আছে প্রেজেন্টেশনে ইয়ে স্লাইডটা দিয়ে দাও না শিবেন্দু স্লাইডটা কমসে কম চলে আসুক
ভিডিওটা তখন তো অন হচ্ছিল এখন আর অন হচ্ছে না তো নেট স্লোর জন্য অন হচ্ছে না কিন্তু
ঠিক আছে
শেয়ারটা তো হয়ে যাচ্ছে শেয়ারটা তো আমি করে দিচ্ছি
হ্যাঁ শেয়ারটা করে দাও স্লাইড দেখলেও ঠিক আছে স্লাইড গুলো তো দেখতে পাচ্ছি না
হ্যাঁ হ্যাঁ এবার দেখাবে
স্লাইডগুলো দেখতে পাচ্ছেন
হ্যাঁ ঠিক আছে এবার ঠিক
এবার
আছে
দেখাচ্ছে তো
হ্যাঁ ফাইন প্রেজেন্টেশন মোড করে দাও একটু বাস
হ্যাঁ ভিডিওটা পরের বার দেখছি নেটটাই
হ্যাঁ ঠিক আছে ওকে হ্যাঁ স্যার প্লিজ কন্টিনিউ স্যার প্লিজ কন্টিনিউ
So you are actually I am fully audible to the students and all the audience.
Yes, audible.
Yes,
clear.
Okay. So what I am actually telling that India is actually producing almost 10% of the total demand of the globe. Okay, about 10 million ton we are producing. Now the thing is that to apparently it actually seems that it is very casting. It is nothing. It is a cavity, and molten metal is just poured into that, and then it will produce a casting after getting from the sand mold. Okay, so and then after that it needs fettling. Everybody knows that, but I am telling you, it is really a challenge to make a quality casting. It is really demanded in railway, in automobile, or many components. I will show you. Even in earth moving elements, there is really a challenge, and yield is a very, very important factor in this particular issue. So every company, as an entrepreneur, their interest to always to increase the yield. Yield of what? The yield of the process, yield of the casting. So it is actually, you know that casting process is involved with the hot metal. Okay, so if you save hot metal more, then what will happen? It will gain, company will gain. So very easily I can tell you that yield means that how much percentage of your molten metal is actually used, and you will get directly cost out of it. Suppose a component is having 6 kg weight, so you cannot pour 6 kg and you will get a component of 6 kg, because I think you have know the basic idea that there should be some pouring sprue, riser, runner, etc. So it will take the other some amount of metal will taken. So if the weight is a 6 kg, but the total molten poured metal is 10 kg, so 6 by 10 into 100 is the yield. So I can say that 6 kg, so for the 6 kg item I have put 10 kg. So if I put 9 kg, then definitely this will higher. Okay, so this is the basic objective. So you can improve your capacity, that means capacity of the foundry, or you can see the total output of the foundry by 2 methods. Either you increase the yield, that means you will gain it, or you reduce the rejection. So yield percentage improving And rejection decreasing is the main motto for any metal industry, whether it is a railway or automobile or whatever is that. So I will show you some interesting case studies, and each and every case studies, there is some small stories are there. Okay. So it is an interesting part. I thought the students may get real flavor of the industry, because industry will give a problem to a person when you can really solve it. Otherwise, they will not look for any consultancy. Okay. So first slide I am showing you. Before that, I just want a very brief. If a small foundry who is giving a product of maximum say 100 ton per month, okay, that means 1200 ton per year. If we think that 60% yield is needed, that means yearly he is producing casting of 720 ton. Okay, and then rest what he will do, whether he will throw it away, no, that actually again he has to remelt it. So out of 1200 ton, 720 ton is basically he can sell, and 480 ton he is rejecting, but again you have to remelt for further use. So it will take cost. It will again cost is about 48 lakh. That means 4 lakh per month. My idea is that if you reduce this if you want to reduce this loss, then what you have to increase the yield. Similarly, if another way, 60% yield, still getting 10% rejection, maybe any other issues, many issues, maybe due to sand, maybe due to pattern, maybe due to metal, maybe for shrinkage or whatever defect is, say 10%. That means the person is basically getting only 50% effective yield. 60% yield from the process and 10% is a rejection, so minus 10, so he is getting only 50% yield. Now the question is, if the rejection I can decrease to 5%, that means average improvement is 5%. Okay, that means improvement, that overall improvement I can think, then it means that if I can improve that 5% improvement, that means it is a earning. Okay, so simply it is a calculation. If you make some improvement of yield or rejection improvement, that means also it is an improvement of productivity. Okay, so I will not take much time on this. Let us go to the actual field. So before just going to the actual thing, I am telling you that casting is actually a baby in a mother's features, we definitely say, till from the pouring to the end of getting the casting. Because when the casting is coming at the checkout, or you can say at the time of fettling, then only I can conclude that this is giving a highly dimensionally, metallurgically and mechanically, it is giving a sound casting. But to get a defect-free casting, it is really challenges offload with, particularly for any material, particularly for steel, particularly for stainless steel, particularly for SG okay, particularly for aluminium. So what the basic things I will consider? I will consider major thing is that proper placing of riser. I should not go what is, I will not say anything on riser. I thought you know the riser. Okay, riser is one line. Riser is actually a extra metal which is provided into the casting just to just to complement the shrinkage, and it should be placed in a proper place and with proper size. Okay, then apart from these above two points, then runner's length is also important. Then total getting feeding system, that means I will come to you details that cross section getting risering gettings and runner cross section, which is known as pressurized and non-pressurized. That detail you can get it from any books, or I will give my email address last of all. And then sand related issues, sand entrapment, and these conditions. So these are the basic things I am giving you. And after that, I am always analyze the each and every castings which I am doing the good result from any foundry. So it is almost maybe, I think it is not less than 12 years back, one casting I got, and the company told me, sir, this is a casting which is used. So you see, just see, this is a big, it is used in a very heavy very heavy earth moving element. You see, it is just like a say bearing. It is a bearing knee type, and this is just a housing. It looks so small, but it is a finished weight is 250 kg. Understand? Now, what is the problem? Huge problem was coming. So company told me we want to reduce the rejection and improve the yield, because this is only giving yield is 46% and rejection is 25%. That means 71% gone. So company is only fighting with 29% of his sellable castings. This is the chemical composition. I am not going detail into it. Now I am telling what they are doing. First, that this is the pattern is the most important part of any casting. So I tried with this motamoti, what is the volume of each riser. I made a solid modeling, and then I see the ingot is towards this. That means 90 degree. So you just assume that total is mold, and this is the negative part. That means it is to fill up by material. So when a molten metal say coming feeding from say sprue, it will come here, its velocity increases, and it will directly hit this inside is core. You understand, it will be hollow, so there should be a core, and the rest part which you are is now you are looking as a solid, that is a hollow part from the mold. So when the material is in and striking any solid part during its molten condition, it splashes like this. So as according to that, what is happening now? They are actually getting, number one, huge number of shrinkage in this part, and this wall, particularly this part at the central part, that means if you see in this part, there is a huge portion, it is unfilled. Okay, so then what they are doing, they are actually cutting the thing and then grinding, finishing, and after that huge amount of rework has to be done, huge amount. So what exactly I did, I first started work with as per their condition. Then I thought, no, it is actually on the flange. Just see carefully, it is on the flange. So make this flange, okay, after just knocking out of this riser and then grinding work to finish it, it takes almost minimum 8 to 10 man hours to finish one casting. So this is called the rework, and after that they are sending to machine shop, and after that I told you that 71% is the actually 29% is the actual sellable casting. So now what I did, I shifted these castings from the flange just to avoid the, or you can reduce the fiddling part. So I did one thing, I have shifted little bit, and I have seen this is, it is coming out of the casting. So I have to see that my objective is that this hot spot, this is called hot spot, and this is the zone where shrinkage will come. So my objective is to throw it away from actual casting towards the riser. So I did that. I did little bit the dimension I have changed. Instead of 4, I make it 3. And not only that, I make the riser in the runner in such a fashion that it should start from one end, and it will circulate to make it more streamlined flow inside the just you think it's a hollow cavity and core is there. So your material is directed towards one end of that and try to fill the whole cavity. So its smoothness become, its flow become more smooth, more streamlined. It is not very turbulent flow. And as well, what you just see, this is the component at that time they are supplying to machine shop. And after this methoding, or after this plan, what I have told you, and that I got, and just one metal, what I did, I did 2 things. I did number of risers I reduced. I shifted the risers from the location, and then I diverted the runner in the in such a form that the flow could be streamlined. See, this is the casting. No need for rework. No sinkage occurs in this zone. So it is smooth and everything. No felting is required. Only just to remove this thing. And these are placed almost outside the flange. So rework become very easy. So this is one of the story. Then what is the result? The result is actual metal poured before doing this work. It was 540 kg. But after this changing, it becomes 465 kg. That means 65 kg savings I have made on a one trial for one casting. Now, if it make is 100 castings, see 7.5 ton of castings he could hot metal he could save. So the yield was 46. Now it becomes 61%. So improvement of yield is become 15%. So this is one definitely is a work I finished almost about 6 months it was taken, because it is not my full-time job. From my teaching and from my according to my time and their schedule of manufacturing, I have to go there. I have to stand in the shop floor. I have seen the difficulties. I understood the problem and solved the issues. So this is another one. So I am just asking, is it interesting? Is it interesting to the audience?
Yes, sir.
Hello. Okay. Now this is my second component. This is also one very good experience I am just setting. It is a component which is used in a it is a textile machine. The machine is being it is being exported by the Indian company. It is basically Calcutta based, but their main factory in Delhi and Hugli in Calcutta. Okay, so this component is using, just see, is a part of a small this is the component. Okay, it is a flat plate and then it is a cylindrical thing, and in between there is a rotating bush is there, rotating spindle is there. So, and after that a plate is there, it is fixed. So this matching, that means this surface and the actual body of the machine should be perfectly matched. Otherwise, it will be rejected at the spot. Now, what is the history I got it? So particularly, I am just giving you the SGR and composition. What was that? Then I am not going details into it. When I went there, it is I can remember it is a fact. It is in 2012 when they know me that yes, there is a person who could rectify these defects. Then called me, sir, please come to my foundry because I am losing my money. Why? There is a rejection is up to 50% rejection because this flatness is a very, very important issue. This flatness, if it is, that means this corner and the opposite corner, diagonal corner, this corner and this corner should not be deviated more than 3 to 4 millimeter by dimension. That is flatness. It should not be out. If it is within 4 millimeter, it is accepted. If it is more than 4 millimeter, they have to reject. So that is why rejection is huge, 50%. And yield is very low. So 60% yield, after that 50% rejection, you just understand. So then almost no profit. Then they called me and then I see this is the match plate. There are two patterns. A pattern means this is a two-part pattern. So this is one part, this is another part, this is top part, this is bottom part, cope and drag. See, there are basically 1, 2, 3, 4 risers are there, and this is core. This is not riser. This is core because it is a cylinder. Okay, so this is the end part, and this is a top part. So end part is also looking very critical. So on this thing, the lubricant oil is going on. So these all dimensions are very, very important, and there is socket rubber socket actually put in that just to arrest the leakage of oil. So each and every dimensions are very, very critical. Okay. So now, so what I have seen, they are putting the, when they are pouring, now this is a pouring site, there are 4 risers, and this is a basically 400 by 12 SGRN grade. So I thought that they are doing, I have just seen simulation. From the simulation I've seen, I understood that these risers are not at all useful. Okay. And not only that, these risers, if it is not useful, then what will happen? This zone will be very much hot, because these riser with the last part of the casting, which to be freeze. So as it is hot, so it will create the 4 big hot spots in the sand, will be hot for longer time. And what is that? Due to this deformation of the, even solidification, after solidification, it solidifies, but due to that hot temperature of the sand, it is slightly deformed. Number 1. Number 2 is that as it is a number of these are the last points. So what it is done, when you sink it is taking sometimes metals from the nearby. So this is the connection here. Sometimes metal is coming out, and due to that there is some taper or depression, is sinkage from the top surface is visible. So I have seen it is a thing. Then I thought, see, you have to very good common sense. I thought, see, these 2 ends, the dimensions should not be more than, deviation more than 4 millimeter. Okay. Now I just thought that the sand density is about 1.8, but the casting density is 7.4 or 7.5. Okay. So definitely, if the molding is not proper or hardness is not same for all the places, then what it will be? It will be deformed. So what I did, I just changed the orientation. Okay. I make the orientation just like this. That means I just change the orientation. Top box will be bottom box will be top box. So this flat part becomes the bottom, and the cylindrical part becomes the top part. So, and see, there is no riser. I didn't put any riser because I thought, let me see. I talked to the entrepreneur. Let me allow at least 10-15 castings. I will see. Now, when I did it, the soft floor supervisors, they were laughing. They had thought that there were 4 risers, and how this professor can do without any riser, because last 5-6 years they're looking that there is riser is very much essential. Some people came, even the riser increase the riser size, somebody decreases the riser size, but ultimately there is no effect on the rejection level. So this is my first trial. I told that it may be 50-50. It may be rejection will be huge, or it may not be any rejection. Okay, but your risk is for 10 casting. 10 means 10 box. That means 20 casting. So entrepreneur agreed. Okay, my 5 साल में इतना loss किया, so another 20 casting nothing for me. But fortunately, this is the first casting. I am happy to say that is a totally sound casting. And from this image, you can find out that there is no riser. Okay, this is a match plate. I have just removed all the risers. So this becomes one of the first casting of SGRN of weight. Each weight is about 10 to 11 kg, become riserless casting. Okay, and not only that, see, getting is modified. Yield becomes 85%. Okay, no deviation is controlled under 3 millimeter. Rejection is less than 3 millimeter. this is another one, very big casting, about 4 to 5 feet diameter, very big core, sorry, very big housing, axle housing. Now everything is fine, but in one side, or there, not only it's a fixed side, anywhere in the total, because it's a hollow housing, so that means there is a huge core is there. The core diameter is more than, say, about 3 feet. It's a very big core. Okay. And axle is very thin. It is not very, say it is about, I think, remember, it is a maximum 12 to 15 millimeter thickness. Okay. But diameter is very big. But there is a hair crack from this end to other end. So problem was really difficult to understand what could be done, because methoding is okay. Other processes I checked, it is fine, but only a hair crack, and not it is coming up to surface. It is coming almost 50% of the surface. From the outside, you cannot understand. But when the customer is coming, they are telling it is a hair crack. So now, then this is the tricks and this is the experience. So what I did, I understood that the only problem may be due to the core. Then what the medicine is, the medicine was just to increase the collapsibility of the core. Thank you. Collapsibility of the core. So I enhance the collapsibility of the core by adding some agent. You can say, if that agent is not available, even from any carpentry works, that sawdust is available at a very cheap price. So sawdust could be added in the code making process, maximum 1 to 1.5%, and that abruptly, after 2-3 days, when the persons actually optimize the amount of sawdust in the sand for the code making, ultimately this thing getting totally stopped. So there's a, see, it's just a concept what to do. I have not spent any single money for that. Only some sawdust I included. So this is one story. So another story is this thing. There is a particular component.
Hello,
This
sir.
is only, yes.
Sorry to interrupt, but sir, please hide the just pop up. I mean, on your screen.
How I will do it, because I am taking the full screen. You are not we could not. It is not visible. Is it not visible?
No, sir. Just sometimes it just hides some part of your PPT. I mean,
Okay.
it's on the screen.
Sir, the bottom portion, sir, excuse me. The bottom portion, there is something coming, stop sharing and all. That
I can hide.
Yes. That
hide
that.
Okay.
Thank you,
Now
sir.
everything. Now everything is visible.
Okay.
Thank you, sir. Thanks.
So this is nothing. It is a manhole cover. You think it's a component. It's a very low cost component. It is not needed. So what they are doing, but this is the item actually export to Canada and West Germany. The particular foundry is situated in Howrah, and they are actually sending that rakes after rakes. In the ship, basically, they are sending the thing to Canada, okay, by ship. So one fine morning, I got a call from them. They said that, see, they are after machining, sometimes they are getting huge rejection, and they are almost sending the whole lot, maybe a few crores money involved. So this gentleman, his owner, called me, sir, I have heard your name, kindly help us. Then I said, see, I have to give at least 15 to 20 days time. I have to think the whole thing. Then I see that they are actually, it is a looks very simple casting. Okay, this is the casting, left, extreme left. Okay, its weight is about, say, 25 to 30 kg. So its cost maximum say 30 into say 60 rupees kg. That means you can understand 1800 rupees or so cost. But if we lose is 100% castings from some company and it is export material, so huge loss. Then I visited the company. I told I standing. I don't ask anybody, any worker. I just stand there and I looking what they're doing. Okay. So after 2 days, first day I stand there and I don't discuss anybody because I know the process. I just think what they're doing. Second day again I went after 3-4 days. Same thing. Then I told, Acha, why you are doing this thing, that thing? A metal is pouring from this side. Why you make this runner bar like that? It was previously in different type. That you just see, I have given this thing here. A man is doing by his hand. Okay, this thing. Okay, he is actually cutting the runner. Okay, by hand with some tin plate. Okay, steel plate. And after that, they are just joining. No dimension, nothing. They are joining. Then what I did, after 2-3 days, I seen and I told them, you just whatever last 2 days you have done, you send for machining in your machine shop so that you can visualize the thing. So after that, after 10 casting almost, I have seen that in this area, okay, this area and this area, they are finding some type of some porous things. So I said it is nothing. It may be two things. Either it is a molten sand, he's just picking up during its flow, or it may be slag. Okay, but I am not very sure. I told I am not very sure. It may be sand also, or it is a slag. Slag may be two type. Either it is solid slag or it is liquid slag. Liquid slag is very difficult to control, but solid slag can be controlled. I thought if it is a solid slag, it could be controlled very easily. But liquid slag, you have to add many things. You have to spend money for that. And also, nobody in the world could tell you that 100% liquid slag I can eliminate. No, I can take some sort of precautions. See, this is the runner bar. I make the end like this. Okay, and this is also they do not know. I tried from say this extra end was not there previously. I make it say about 35 millimeter long and say taper of it is about say 40 to 45 degree taper. Okay, they don't know why I am doing. Now gates were of the this much of thickness. I make the gate like this at the bottom of this, and then I made this type of thing. Initially they don't allow because they said it is difficult to make. It will slow down their process. It will decrease their intensity, yes, their incentive. So they are not ready to do it. So this type of defend sometimes they are doing. So I said, okay, you do at least for 5-6 castings, and after that I will show you. Because if it is rejection, you will not get incentive for that. They said no. Then I got this type of runner, and I got another runner which was conventionally doing before going me. I told that you break the two, and then the defective runner, what they are making. So I showed them, see, the metal is, this is the top part, that means that this is the part, and you are putting gate here, and then the slag is flowing into the casting. And now see, in the bottom part of the runner, see the metal is good. Always it is good because slag is little bit, you can say less density, it is lighter. So slag is always floating. Okay. So what I did after that, I understand the problem and they accepted this thing. And this is the final product that I just showed you, that there is no such, see, this is the, if you can magnify this, you will find out the metal is coming, entering through this, and there is no bad elements in there. So after that also machining, nothing came up. So this has been passed. This is a product. This is also railway product, very costly product. It is a low carbon steel product. It is a casting a company, I can remember it is in Asansol. I'm not taking the name. And the same thing was happening. No, watch it. Sorry. This is also grey cast iron. Sorry. It is also one sort of manhole cover frame. Same type thing. They are getting some slag, a particular place. Very typical. Very particular place during machining, particularly I think in this place. This was something coming and the casting is ultimately rejected. What I did, I did the only thing. See, this was the basically their feeding system. The problem is, you just check it. See, sometimes it is not there. Extension, I think it is not there. So initially they did not make any extension of the runner. It is inside runner. Normally we are putting the runner in the outside of the casting. But this casting is very big. So outside, if I make the runner like this, the yield will be low. Okay. So inside they are making the ingates like this. And this is the one position of the screw, second position of the screw. Okay. So two gentlemen are simultaneously putting the hot metal in this. Okay. So I said, you are doing some mistakes because there is no scope for eliminate the slag. So eliminate the slag, particularly grey cast iron is a very, very important, because grey cast iron is one of the slag producing, because a very fast slag is being produced from the molten metal to in the casting. So the restriction or control of slag is very, very important. So this is the thing. After I can remember that I have just changes I have extended this, I extended this, I extended this. So what is that? The slag is coming in the ends as earlier, and the gain gate position I have not elaborated here. Same thing, and ultimately the castings getting passed. That means no reaction getting decreased. So this is another one case. See, this is from the Asansol some casting unit about 6 years ago. This is the component of low carbon steel, I think, what I can remember. So this is called one sort of, this is about say 45 kg weight for a single casting. So I have to first check what is going on in molding, what is the going on methodic. So they are saying there is no runner work, this is the ingot, and from the top they are pouring this is a point. Okay. So I said, then how the slag will go? They don't give any answer. They said slag will come inside. So I told that is why your whole material is slag is not always it will be here, always it will be here, always it will be here. It may be stuck up somewhere in between because he could not move. Is a lighter one, and if the slag is more thick, so it will just make a blockage in the passage between the mold walls. So you have to change the thing, and not only that, you have to change and you have to make the getting ratio very correctly. So see, initially they are sending like this. I just changes the ingot position. You just check, it is just radial. It is a radial direction. I make the thing in radial direction. Okay. So the first example you just think of. So metal will go inside and it will flow like this and it will fill the mold. So first I tried with this just to show them that, see, because when I change from here to here, that 100% casting is not okay. I'm telling you frankly. Then I increase the thing, this part. So this part is increasing means, as per the fluid mechanics law, when the material is going inside, it will first moving to the farthest point of the casting. Okay, very fast. It may not fill, but first of all it will go. Okay. So then solidifying starts from at this place. So when a metal is getting poured, you have to very cautious that the ladle, even after skimming out, particularly for the steel, some slag or some side of sand or something, or if your that getting ratio is not proper, and particularly I'm telling you very careful about the steel, that it's what I can remember, the Reynolds number is much more than the cast iron and other alloys. Okay, so particularly steel, it actually try to erode the sand. Okay, and because its a temperature is also at least 2 to 250 degrees centigrade more than the normal average of cast iron. So you have to be both way, you have to be very cautious for the steel casting. The getting ratio should be proper and its flow should be smooth, not turbulent. So this is the thing. Only thing is concept. I have not taken any single paisa that do this thing, do that thing, do this, do this. No, only by methoding only I have done. This is my. I am telling you again. This is a takes time. It is not that only one sitting I give this thing. After 2-3 sittings, after standing there, and I have seen why it is coming. Even ladle should be very clear. There are many other points are there. But if other things are constant, still from the methoding side, you have to continue like this. You have to do this. So I think if you are interested, so I can carry another one or two. I don't know. Dr. Paramanik, is it interesting? May I move further?
Yes, sir, it is very much interesting. And I
Okay,
hope the
because
students should also hear that we should go for more case studies. So you continue with the case studies, sir.
see, this is the experience for my last almost 2001 to 2018. You can see before joining. Still, I am doing this thing, but I am doing it is just like a fun. Okay, it took more time because I am not running to the foundry from Imphal to any part of the country. But nowadays, technology is very fast. Okay, so they are actually helping me on online also, by video also, but I have to carefully see when I am really free for that. So again, I want a very good example I am showing. It takes even more than a year to solve this issue. The case study number 7. It is a small worm gear. It looks very small. Okay. And in match plate, there are only 4 castings are there. It is a worm gear. Okay. Material is steel. So far I can remember. Low carbon steel. Even after simulation, just think, out of these 4, some one of the casting is getting sinkage at the middle, and middle there will be a key slot. Okay, because this worm gear will be fitted in a shaft, and then a sang key is being fitted. Okay, now if there is a small discontinuity or hole or any shrinkage, even at the size of your mustard seed, okay, mustard oil seed, that means 1 millimeter or 1.5 millimeter, even 1 millimeter, I'm telling you, it is reject. Okay, it's a very I think it's a handle of a lathe or some machine tool, I think. So even after this simulation, sometimes simulation cannot give you the full picture. Whatever the simulation software cost is much level is there from the magma to any, I cannot say the names, but I can say the highest cost is the magma. Even I have corrected, I can say proudly that even magma failure with the experience of any person. I am not claiming alone. There are many persons in the world who, with their experience, they could solve. Even magma could not solve. Okay. So one example I am telling. So sometimes it is giving 4 is good. Sometimes most of the cases, that is out of 4, 1 is rejected. So after 1 year, I have changed many things. I have changed gates, I have changed sprue, I have changed the practice also. From where the metal is being poured, मैं खड़ा होकर के उधर में बोला, now we just low down the ladle so that the velocity will be less. Okay, I have done many things. But I am telling you very frankly, I could not do. After almost 3-4 years, one day, their owner is telling me, sir, I can spend you anything. So can you just take some risk? What risk? He is telling, sir, total match plate I will change. Because there is some problem. Because your failure means there is something problem. Okay. And last 2-3 years, almost 15 to 20% rejection. But our target in Indian industry is about below 10%. In foreign countries, in Japan, you will be surprised to know they don't allow any subfloor, okay, more than 1% or 1.5% rejection in the casting. Okay. Otherwise, they will throw the supervisor and they will do something else. Okay. But in our country, we are a little bit lenient in that. Up to 10%. Nowadays, some foundries are allowing 5 to 6%. But normally up to 10, okay, theek hai, chalo. So this gentleman up to 20%, and then after that said, what to do? Sir, you think something. So we thought, let us do something. Try. I said, you make the core, not, it was previously a green sand. Now it is a no-bake sand, okay, and it is being prepared in a core suture machine, okay. Just imagine, it is just a 1, 2, 3, 4, 5, 6, 7. It is a 7-storied building, you just assume. And this is the lift, or you can say common channel. And it is going to the all bottom. That means it's ultimately it is bottom pouring. Okay. Bottom pouring, the preference is that bottom pouring always gives you best possible surface finish of the casting. But sometimes it is not possible. Virtually not, practically it is not possible. That is why we could not done it. But now they have given me the flexibility that with the manager, he could do anything. I will bear the cost, that entrepreneur told us. So after almost 6 months, we have thought on that, how to design and then make this type of thing. Okay. That means this is a single pouring. We are getting 1, 2, 3, 4, 5, 6, 7, 8. 1, 2, 3, 4, 3, 7. Total 7 into 4, 28 castings. Okay. So number one, you are producing, otherwise you have to put 7 boxes. Okay. So you are reducing the subfloor area. That means within only one box area, you are making 28 casting. Instead of 4, you are getting 28 castings. And in between that, see, this is the, just assume, this is a total solid cylinder from the bottom. Only we are gas cutting. Okay. See, then this, the middle, the yellow dollar, this is this rod. That is the main screw. And see, I surprised after the simulation that the color of this thing came in such a fashion, not a single rejection will come. So after this simulation, I really inspired. I excited. Then I said to the entrepreneur, let us go for the practical trial. First, I done it simulation. So this was previous. Now this has been made by the cake course. And similarly, one after another, we put together and make, see the 1, 2, 3, 4, 5, 6. You see 7 boxes are there. This is the middle pouring. These are the ends where the material is coming out. So still we put a very small riser with some sleeve so that metal can stay liquid for longer time. Okay. So after checkout, I said, don't cut. Okay. And you cut it in front of me so that I will see it. Okay. Then after that, see the, you can see the, understand the, what is the coming out. Say previously, the one bunch means 4 castings, actual weight with runner riser 20. That means yield was 48. Now, the stack molding, it is only 100. You are getting 28. See the yield. But apparently I thought it may be yield may be decreased. First I calculated theoretically. Then I said it may be around something. So ultimately when I do it, cost analysis chhod do, baad mein, but it is not also much. If you want, I can show it to you. So see, they see meant ultimately I seen that material cost, everything we have seen, but that rejection is almost nil. I do not know whether next page I can show it to you. A minute. Oh, this analysis, I sorry to make it, but only thing is that you see the total cost and other things, short blasting cost, everything. But I am getting the metal cost rejections. I forget to make it, but rejection is absolutely nil. Absolutely nil. Okay. So this thing still they are adopting for last more than 6-7 years. So this is another example. Okay, a very typical thing. I do not know whether you understand or not. This is actually clipping with the that fishplate type. Okay, this is a gap where the rail part is there, and it is just putting into that. But this is used in American railway, and this PRS should not be disturbed in any means. And it is so depth, you cannot print it after casting. Then cost. Hello. হ্যাঁ, তুমি একটু ঘোরাঘুরি করে এসো, ঠিক আছে? কাছাকাছি বেশি দূর যেও না, কারণ 9টা, হ্যাঁ, কারণ 8:30 9টা নাগাদ। আচ্ছা, তাহলে তুমি ওখানে যে গার্ড আছে না, তুমি তাকে বলো যে স্যার এখন লেকচার দিচ্ছেন এই এনআইটির জন্যই, আমি এখন লেকচারে আছি, তুমি ওনাকে বলো, উনি অ্যারেঞ্জ করবেন, না আমার লেকচার আধ ঘন্টার মধ্যে শেষ হয়ে যাবে, আমি দেখছি, ঠিক আছে? ওকে বলো, অ্যারেঞ্জ করে দেবো, ঠিক আছে? ওকে। So see, now this was the actual conventional process of doing the thing. Even I have simulated, as I could not put any riser in the top because then this will be disturbed. So always I use side riser, maximum side riser, which could be possible within the box. I have put that, and not only that, it is a sleeve, that exothermic sleeves are there. Still, not all, but maybe about 10% I am getting this type of rejections. Okay, and I am telling you, I am really frustrated with that. I tried after tried, maybe more than 1 year. Then again, as like earlier, we thought if we can do in this fashion with a bunch of the things, okay, and then let's see, because yield we can improve. So first, this is our first simulation where we made with one casting, one riser, one sprue, just to check. Just you see in the left this thing. Then I cut it and seen it is very absolutely okay, no problem. Then we made, there is 7 castings with single sprue, runner, and put the riser every time. So this is a solid model of the bunch. Then see, I have got the simulation, but again I'm seeing there is a hot spot. But then what we have done, we changes the, see, you have seen that. Then again we are changing, we have done many researches on that. Then I said, see, if it is given yellow, maybe sometimes it may not be correct. This is some example I am telling you, where software is not give directly direction, correct direction to the engineer. Okay, so even it is showing some yellow, I said let us try. Okay, because I could not do anything better than this. Okay, I surrender. Unfortunately, This is the photograph I taken when the casting was being taken. So this is the casting, and you see all engravings are clearly visible. Customers is satisfied. Then I see, let's go for the cost analysis. See, the bunch weight yield is not improving in the production yield, in the bunch yield. But when I'm going to the rejection, I am astonished. Previously, rejection was about 30%. And it is totally unpredictable. Unpredictable result gives a very, very bad name to the entrepreneur. Because some month he is doing very good. Sometimes it is high rejection. So they could not fix their productivity in a standard or in a, you can say, much more consistent manner. Consistency in rejection, whatever may be, 5, 10, 50, whatever is that, it is very important. So first I can understand, they see 5% rejection. So then cost wise, we find out it is only nominal cost, only 1.5 rupees or 2 rupees extra. So their entrepreneur, not only that, processing time becomes 1/3. So the entrepreneur is very glad. But again, I am telling you, it is almost 1.5 years, even more than that, we have tried with that. So these are the very, very typical experiences in soft floor. So if you are really curious, see, this is one casting. The company is far away from this place. It is near Kalka. They are somehow got my name from Indian Foundry Journal. Okay, because if you go in some Indian Foundry website, you may see my name as a casting say simulation or something expert like that. It was sometime. I don't know whether it is still there or not. See, this is a component of solid modeling. It is a steering case of Bolero car. And then is a very, very complicated design, very, very complicated. The complicated means the sense in casting, the complication means the surface or thickness is not consistent. जितना variation होगा, যত বেশি variation হবে, তত সেই castingটা তত বেশি difficult to produce, difficult to. The problem is that the first they sent this, I said without any riser I will see where is the spot, and that spot are the maximum difficulties are coming. Okay, I can give the medicine by pressing the riser, another thing, but still I have to see where is the problem. See, these hotspot area, finally I have seen they are making some drills because it has to fit somewhere. When it is drilling, if there is a single sinkage or something is there, discontinuity, the material will be thrown because it is the name of the Bolero company that it is not fitted properly. Steering is a very, very important thing. So sinkage occurs. See, I have seen with this. See, these are the points where I am locating. So I visited the factory. Okay, this is, I am standing and taking the photograph. Then I said that first of all, this is not correct. Okay. So they did not act. First of all, any soft floor person, when you, I am telling you very frankly, when they know that he is a professor, they do not know how far the soft floor experience I am having. Okay. So first of all, they deny it. No sir, kaise hoga? Ye nahi to nahi hoga, ye hoga. This problem will come, that problem will come. Then I discussed with directly to the owner. I said I have to give some risk, you have to take some risk, and I have to give the chance to make operate of this particular issue. Okay, if you are ready, I will go. If you are not ready, forget. I am not taking this case. So like that, first I tell you, this thing is wrong. Okay, how I said, you can ask me, sir, why you said it's not correct? Because I have seen that these are the areas where the metal is entering. These and see see the cross section. See the cross section. So this is not uniform. Uniform cross section on non-uniform cross section means, as an engineer, as a science person, you can understand the velocity of the metal, this place and this place are not the same in the same casting. So if that means this part can fill easily, this part will fill in late. The velocity this part is very high because the reduction is cross section, because the velocity at this point is same. Okay. So now after that, I change the thing. You see, there is no such thing. Is there only two? Same, this and this. And I said that as the casting is very critical and very difficult cores are there and huge number of metal is there. Here I cannot think for yield, particularly in the match plate point of view, because this is a very, very safety item. So you have to increase the yield by reducing the rejection. So I tell that I cannot give much yield in that. Whatever you are getting, I cannot. Then the man said, you reduce my rejection, I'll be very happy. So I said, you have to make to just exit. That means for the gas, huge gas is developed because the amount of core is more, volume of core is more. So huge gas is generated. You have to make the passage to make the gas so that it can escape easily. So it is nothing, just a plate of 2 millimeter thickness, and I put into that. I told them to put like this, as many as possible. So they did on the same day. I was there for a day, and then I saw the next day I have taken, you just take the casting, and after that they sent, and they were very happy with that. Then ultimately they said, sir, it is really good for us. So this is one story. So I did one time, but the thing is that before that I have seen many rejections before going there. Okay, as it is very far, it is not possible to go regularly. I go only once, but before going there, I have studied the nature of defects. So I can quickly finish this thing. This is a part which is very near from here. I think it is in near Raniganj or something, some company. So this is a component which is again being used in railway, okay, for fixing the fish plate. So there will be some other parties there. I do not understand exactly why it is using. It is almost 2 point something weight. But the problem is the entrepreneur said that our match plate is like this, okay, and we do, these are the small risers are there here, and there should not be any defect inside. I don't think about the, you can say, yield or whatever is that, but my margin is very low. At that time, at this, it is 10 years back, the margin was, he was telling only 25 paisa. Because huge count that, because company is existing, because they are supplying more than lakhs of these pieces per month. Okay. So this is the casting. So what I did, I said, okay, I'm not getting very sure, but if we change little bit, I can think. He said, you can take any risk. So I started with this, with the unmodified match plate with only 12 inserts. Then what I thought, I said, can you just put one component in this part? But there is again, I am told them that there may be chances of entering slag. Okay. So you have to do the slag removal, very, very good process with very expert ladle making maker, that means who is actually skimming out the molten metal before pouring. So they said, okay, we'll try, because this is our bread and butter. If we don't improve our, increase our profit, then we will be, company will lose. So see, with the same match plate, I have put two inserts. So I make it, instead of 12, I make it 14. So ultimately, they are very happy. I am not going details into the methoding. I am not changing anything. Only by chance I thought that if I make it, sometimes you may get scrap, but I have no chance. I cannot help you anything. But simulation said that make a metallurgical, it will be okay. If the slag enters, I could not do anything, because I have no scope of escaping the scrap from this match plate. There is no space I can escape. So next, it is a very good story. At least if you want to finish me here, I can finish, but I don't want to get relief if I don't say this story. This is a story maybe 15 years back, when I was really started consultancy work, okay, in 2005 or 6, I think, minimum 15 years ago. The foundry is which is making that kadai. That kadai is made of cast iron. Okay. So suddenly the entrepreneur called me, sir, I am getting kadai which is unfilled. Everything is okay. Metal temperature is okay. I said, how you get the thing that your temperature is okay? He said, I am doing it for last almost over my age. When my age was 10, I am now more than 60. So last 50 years, I am standing in the same foundry as a owner. At that time, I was child. Now I am old man. So I am saying, I know that temperature is no problem. I said, your sand quality same person is doing, everything is doing fine. Then what is happening now? I am trying to fill, but it is coming. They said jali. Jali means it is not fill the full surface. Okay. I am not going details, because I do not know how it is just a hemispherical. One is positive part, another is negative part, and mold is making like this, and metal is being poured. Then I said, okay, I will visit one day to your shop floor. Then from the morning I just stand and everything I seen. Then from morning to afternoon, when they are removing the kadai, they show me, sir, it is not filled. But even 15 days back we have done it. The same material, same, everything is same. So where is the problem? Then I asked him, let me show all the kadais in your factory. Factory is very big. Then I was just moving around his whole shop, and then I see outside their shop there is a pond is there. Okay. Then I thought pond to barabar hai, to why it is a problem is creating. Then I again just enter the shop, and I seen when they're making the sand quality is almost same as other foundry. But when they, after molten metal, when they try to knock out the box, at that time I seen the sand is full of water. Then they are telling me, sir, how this water is coming, we could not understand. Pani aa jata hai. Then I understood what is the problem. Then I said, there is no problem in your mold making and no problem in your metal. Okay. And your people who are working, there also no problem. Only thing is that when the metal you are putting into that, suddenly the mold, how much percentage moisture is there? About 3 to 4%. So immediately it becomes vapor, okay, and it creates a vacuum, and then the water which is surrounded by okay, which is at the low of say almost 20 feet, because it is done on the subfloor itself. It is floor molding, no box and nothing. Okay, box is there, but it is floor molding. That means on the floor they are making this thing. So after that, he said, is it like that? I said, yes. Otherwise, you do something, you just go to the little lower elevated portion and do the same thing, bigger kadai there, and you will see there is no problem will come. So at least I did nothing. I only showed them, said, don't do this in the particular rainy season, because the water from the pond will come and it will create a moisture immediately, and so that no molten metal will enter, because your mold is filled with the steams, vapors. Okay. So this is a wonderful experience from my side. So, gentlemen, another 4-5 is there. Okay. Hello, Professor Paramanik.
Yes, sir.
Am I close here, or people are getting really interested? Another 5 cases are there, but it is very small. So should I complete it, or I will go for the next slide for that smart foundry, or I will close it here. Smart foundry, I will take only 5 minutes.
So
Can you ask your students whether it is interesting, or you people tell me? Otherwise, I will close down by next 5 minutes.
yes, the students are there to answer.
You just ask the students. It is your students, and you are
No
your
problem.
teacher. You ask them. Is it creating any sense? Then I will continue. Otherwise,
Sir, sir,
Another
they
five.
will another. You continue this 2 or 3 slides. You continue, and then you move on to your smartphone.
Okay, fine. So
And the 2 case
sometimes,
studies.
okay, no issue. So this is one case study. It is not. It is very simple. Any engineer can understand. But initially, the people, soft floor people, they could not understand sometimes the hydrostatic pressure and other things. Okay. So this is a casing of a pump body. So they are furious when this is coming regular sinkage. Okay. So I told it is happening because your top box is very low. Okay. And your this height and this height are not same. Okay. So your box should be such that molten metal should be at least higher side. Otherwise, there will be shortage of that is the main problem. So your sprue should be at least in the high. That means your box should be more sufficient. Sand should be there in the box. Okay, because these are tricks. Always workers in the soft floor, when they are handling the mold boxes manually, always they try to make the smaller boxes. Okay, so that they could handle the less weight molding box. So it is just for that the remedy is you have to enhance another 1 inch at least the sand thickness. So this is another one thing. This is inconsistency in mold pouring. Sorry, mold. The consistency means it is the compactability. I think people knows who are reading foundry. So hand compactability should be at least 45 plus minus 2. So if the comparativity is not there, comparativity is the index. So making the uniformity of the mold box. So if it is not there, so you may get, it is also a component pan, the kadai. So it may be making hollow like this. Okay. So it, from the outside you cannot understand. But when you make it crack, in between you will see it is not filled like this. Okay. So it is because of that compactability, because cast iron, you know, as a graphite formation, it tried to expand. And when it expands, then it creates this type of problem. So it is one sort of mold wall movement. So this is again some hair crack. Hair crack means most of the cases you have to think for the core, because there is a other side. So there is a small core is like this. So if the core shrink, metal sink. If there is a both of them shrinks together, then there is a chance of 50-50. But if the core sinks earlier, okay, and it collapses earlier than the metal solidify, then it is the best. So again, the same problem what I said in case of hair crack, that is you have to improve the collapsibility of the core. So this is the last case study, I think. So this is my first consultancy in my life. It is in 2001 or 2, I think. I just came. It's a long story. I'm not going into that. Only thing I have seen that this is a match plate. At that time, I was not doing simulation. I was doing hand calculations and other thing. But that company was doing the simulation. So in 2001, I first see in Howrah there is a foundry. It is a now very big foundry now. At that time, it was very new, but I have seen simulation in that time. So I have seen one very peculiar thing that everywhere there, wherever they are thinking, they are getting some sinkage, they are putting some sort of riser and again some knockoff like that, like this. So it's enormous number of risers you just see. Now casting is haphazardly, no distribution. Metal is coming here, one side it is producing 1 and 2, other side it is producing 1, 2, 3, 4, 5, 6. Okay. So ultimately I thought that it is yield is 47%. Not only that, it goes down because of high sinkage is also coming, at least some 1 or 2, because this number of risers is actually working enormously, but no prediction, nothing. So this example of the nature, I found that if the water is coming from the different sources and merge somewhere, then it is actually some splitting takes place. Okay, as I said in my first slide, show the behavior, the flow inside the molten metal of the inside the mold is very, very important. It is only common sense. I am nothing going for any theoretical issues. That is why I'm telling you. I will just give the story and experience of my life. So I thought, if I do like this, whether it will be useful. I said, see your match plate, I have reduced. These are not the risers. These are the pads. Okay. So I have only making small riser, 1, 2, small riser. Even it was not needed, but that gentleman with the owner is not very confident on me, because at that time I was very, see, just you think my age was 20 years less. Okay. So this is also sometimes important, that how much experience is there. So instead of this, okay, casting yield was this, their number of producing almost components are 8. Now I am making 7 components, okay, but in improved yield and no sinkage. So ultimately he has taken. So I think these are the some riserless castings I have made for SGRN, particularly 507 grade, and see the yield. And these are all I have done almost last 4 to 5 years. Not last 4 to 5 years, you can say from say 2014 to 2018, before joining NIT Manipur. So this is the thing. So I think I am going the end of this chapter. So if you are really interested, I saw another one slide for just 5 minutes. Okay, if you're interested, it is on the industry. Dr. Paronik, I just giving 5 minutes for this
Yes,
IoT.
sir. Yes, sir. Yes, sir. You continue with the smart mode.
This is smart, means it is not that it looks very smart and other things. Smart abbreviation is that from the third slide I can show you that sustainable metal casting by advanced research and technology. Now, I don't know whether you understand Industry 4. What is the meaning of Industry 4 is that Industry 4.0 means it is Industrial Revolution 4.0. Okay. When our you can say our forefathers started their life regarding the earlier part of the civilization, they could do everything by their own hand.
Excuse me,
Slowly,
sir.
yes.
Sir, slide show তে করে দিন না প্লিজ।
আচ্ছা,
From current slide করে দিন, তাহলে এটা ভালো দেখা যাবে।
এটা খুব ইম্পর্টেন্ট স্লাইড।
হ্যাঁ, ওর জন্য।
It is a very important slide. When first
Yes,
mankind
thank you.
starts
Thank you.
that mechanical production with machine powered by water and steam. Okay, the steam engine just evolved, and then people started steam engine for the usage of machines. Okay, so this is our first industrial revolution. Second industrial revolutions came about after almost 100 years after. What is that? At that time, people said if you go on production with this, that then the component production rate is not very high. So we have to go for mass production. So it is basically a repetitive production. Main concentration on repetitive production. Then again almost 70 years after, so now the computer is attached with the machines, machine tools, CNC lathe, CNC milling, CNC drilling, CNC laser. Now it is becoming computer numerical control machine. Initially NC, then CNC. So this era, when complete not NC, when CNC came into picture, then we said it is industry 3.0. Now, when all these things is adding, and with then cyber physical system, that people can take data from the cloud computing, and people can store data in cloud and sharing from any place. Okay, and not only that, that internal foundry or whatever may be the manufacturing system, all machines are fitted with sensors. Okay, so that they can talk each other. Talk means they can send their message from 1 to 1, 1 to 3, 1 to 5, like that. So now then it may be the industry 4.0. But India, I am truly speaking, this is a project which was given by a group of faculty members. I was a part of that. There were 4 principal investigators were there. There were 16 faculties from different engineering college institutes, IITs, NITs, Jadavpur University, and there are 4 PI and 12 co-PIs are there. I am just showing you, just for your information, that see, this is the 4 PI, this is the co-PI. After that, some again joined, some industry, 10% funding came from the industry. So now I am just going to tell you the most important slide. See, this is the industry, say even 40 years back, even today it is moving. Nowadays, little bit modernized, pallets automatically moving. So one constant place. So you can change, you can see the change from here to here. But now our future industry should be like this. Okay, this is our project. Project is not completed so far. And here with the 16 faculty members, about 30 research workers, GRF, and now they are SRFs, still working. It is already first phase, government, DST has already seen this thing, but it is just again demo version has been shown it to them. The thing is that it was a 0 version. From the starting, it's a CAD model. CAD model, from that it can be made in the pattern is made in the 3D printing, and then it is made a mold in the Novak molding, and then methoding could be checked by the simulation, because it is a part of the digital manufacturing. It will be manufactured, it will be simulated, and get the conformity of that. So like this was the 0 version in IIT Bombay, and this is the tabletop furnace, induction furnace, 1 kg. So this is the mold box manually, and if you pick this thing, metal will drop. But after that, the version 1 came. Then these are the background. This is the design part. All has been clubbed together. The sensor part, monitoring part. Now the last slide, just 2 minutes I will take. So in this rapid casting process, methoding 1 part, then simulation, then 3D printing, sand molding. It is a Novak sand, then direct casting, and then 3D inspection. So far, this part is not being added in the actual system. It is our plan. So I am not going very details. I am just going almost last slide, just for taking, just saving the time. So this is the component. It is just micrometer screw gauge, because this system particularly instructed by our DST that it initially you should go for only two alloy, aluminum or magnesium, because they are low melting alloy, and you have to take very good precision casting. So it is a micrometer or screw gauge body. So this is the casting. So this is the modeling after the simulation is done. So this is the 3D printing done in particularly in it is a you can say indigenous making by some of the participating institute, and this is the Novak mold. So this is the total picture. This is the automatic molding machine. Initially it was developed in CMRI Durgapur only, and after that CMTI Durgapur, and this has been molding unit. It is a it is basically a composite also can be done, because composite also another one chapter of this total project. So this is the vacuum chamber. There is a furnace. So mold is being prepared like this, and whole thing could be monitored and seen in the computer. So this is the, I think this is the last thing. So I thought I will give the, again I am going to the first slide. So this is the basic idea of the smart foundry, that it could be the whole, that means suppose it's a this is signifies that CAD, the one drawing came from customer, and say part maybe maximum 1 to 2 kg, then CAD model could be done here. Then this is the part where the 3D printing is used only for making the pattern. Once it's making the pattern, then mold is producing here. Novak sand, this is sand mixing by Novak, and then all sensors and other things are being controlled. So one particular man who is at least know how to handle it, he can control from this dashboard. So this is one part, and after that manually only he is doing manually the mold box from here to here, and this is a melting unit. As it is a Novak sand, you know that reclamation is required. So this part is not yet done, but it is trying to do. And after that what is that radiographic analysis, this is also not done so far. So basic objective is that just it will make some batch, small batch size. It will be repeat manufacturing process, quality, sand cast, cost less than 3D printing. You can logic on that. Why you are not going for that metal cast metal 3D printing metal? So 3D printing metal cost is very high. Only thing it will, this process can be replaced, or you can much cheaper than 3D printing metal 3D printing. But the basic objective is to create our entrepreneurs in one way, who should be less than 25 years, that means young graduates or 1 or 2 years experience. This investment should not be more than 25 lakhs if it's done in mass scale. And this is a factory, small factory, which could be done in 250 meters, 225 meters square, that means 250 square feet. So this is the basic idea. So thank you very much. Just I am giving you the concept. You can ask me, sir, why this small component, this you are proposing this thing. The idea is that this type of components, what I have shown to you, that is a micrometer body, say maybe 50 grams or 60 grams. So big companies, they will not be interested to cast such type of small components. And there are many such type of, say your laptop hinge, it is a zinc alloy. So if I can remember one of my laptop, I changed the zinc, one hinge 2 years back. It is only weight is maximum 45 to 650 grams, but it costs around 2,800. Okay, it's 2,800. So it is not the cost by the weight. It is cost by this finishing. It is cost by its usefulness. It is cost by its challenging in manufacturing. So thank you so much. Very briefly, I just given the idea of the two issues. Particularly, first one is completely indigenous, and it is my idea which I have shared with you. And second, actually, it is I am a very small part of that. Even officially, I am not the part of that, because this project I have handed over to some of my faculty colleagues in Jalupur University. Just I am sharing with you because just to share the concept with the young generation, show you are the future engineers, and if you are really interested, well, I think government will allow us after 2-3 months, and maybe government proposal is there that it will be given to all some of the IITs or polytechnics and engineering college, maybe 300. I do not know, not very clear, but there is some policy that government can make it in a very mass scale and give this thing to all the colleges. So the metal casting should come to the college level, and it will be done very easily. And small components can be done within a day. 8 hours is sufficient to work. So this is the concept of and a man can work even he is not very expert in that. Hello. It is open. Okay, thank you.
Thank you, sir.
খোলা আছে খোলা আছে আর বলো না শেষ হয়ে গেছে Okay,
Hello.
thank you.
Thank you, sir. So it was hello. Can you hear me? Can you hear me, sir?
Dr. Polonik has completed any questions?
Yes, sir. So it was a nice presentation. I would like to. It was a thorough understanding of Foundry. It was a thorough understanding of Foundry with the help of the case studies, and basically the Smart Foundry or Industry 4.0, which you added at the last, was really worth seeing. So I would request, I would ask the students or the participants to ask any questions to our guest speaker, Professor Gautam Sutradhar. Any questions from the audience, please? The students or any faculty members? Hello? 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 Hello?
No question. So you can conclude and stop it.
There is no question from anyone? Sir,
Okay.
I would like to ask you one thing. I would like to ask you one. Sir, this Industry 4.0, this modernization of foundry and everything, okay, how does the NIT Durgapur can benefit from it? Can NIT Durgapur be a part of it?
Now, see, first of all, we have to get you have to final presentation to DST, Department of Science and Technology. New Delhi is not yet done. Okay, only last month, if I'm not wrong, 29th or 26th September, there was a presentation showed to DST. Okay, even they find that some little part is still left. So hopefully it will be closed down by this year only, by December. And after that, government will take a policy, okay, just for the how this idea or how this benefit of the project could be shared by other institutes, or not only this NIT Delhi, other all NIT Durgapur. It is for all NITs, polytechnics, ITIs, even IITs. Okay, so that it could be shared by other institutes also. Okay, so this is a policy of the government. I have heard some meetings because I have attended many meetings before. Only 1 year more than that is taken to formulate this project. Okay, and project started in 2017 in September. Almost is going to finish 3 years in September, already finished, but government has given only 3 months time due to Corona and other thing. Okay, so I think you not only you, other NITs or institutes will get benefit out of it. Thank you.
So, sir, again from in MMA department, NIT Durgapur, we thank you all. We thank you very much for agreeing to give this presentation on a day.
Thank you. It is my pleasure.
Because you had already started the Indian Institute of Foundries Durgapur Activity Center today, and in spite of doing that, you have taken your pains to assemble all these case studies. Nicely, you have arranged these case studies and presented to us. Hopefully, the students who dislike this foundry part in the metallurgy department will be getting interest and will be like to interact with you in the future projects.
Thank you.
I also thanks all the participants
Okay.
for coming in, and I would request all the participants to give their feedback. The feedback is there in this the Google format in the chat box. Please spare a few seconds. It will take a few seconds to give the feedback. Thank you all. Thank you very much. Thank you, sir, too, and thank you,
Okay.
Shivendu, also.
Shivandu is still now here.
Yes,
And
I heard his voice.
Yes,
for helping you.
if at least one student get benefit out of it, at least one, and one
Yes,
faculty member, I will be very happy for
Yes.
delivering this my almost 25 years experience in this particular field. Okay, thank you so
Okay,
much.
sir.
Good night.
Good night. Good night.
আমি অনেকবার ছেড়ে দিতে চেয়েছিলাম